Hey, I was just gonna make a really quick video to show people how to calculate this in case someone needed to know how to do this weekend on their own. And I actually did this one time and my writing was backwards, so I'm just gonna kind of walk through it again. You can measure these things with a ruler. You could do that on your screen, but actually what some people are finding is that if you use this little like line function in the slides, that it will actually tell you the size of the lines that you're drawing. But they actually have to be either horizontal or vertical. So there are some weird things that have come up, but I think for most things it should work. If you right click and you just go to format options on your line, it will bring up this menu. And so what I did was when I was looking at this under the 4DX objective, I had already measured the 4X field of view, and this is the part that I've already done. So I'll go, but this is your measurement, and then you can calculate. So if the magnification goes up by 10, the field of view will go down by 10. So now I know that the real size of this field of view with the 40x objective is 0.4 millimeters or 400 micrometers. So you just multiply, there's 1,000 micrometers in a millimeter. And because this is, in real life, this is 0.4, and I'm trying to measure this tiny cell, I use micrometers because I know that I'm gonna be measuring something really small. So what I can see here is that, and I tried to make that exactly flat, it's not exactly, but it should be about 4.47 inches, and that's the size of my field of view, and it actually helps that I cut this down to exactly the field of view. So what I have here is essentially, and actually let me make this bigger, I have a conversion factor where this is my field of view, right? I know the size in the drawing and the size in real life. And so that's the thing that I'm going to use when I'm trying to figure out one or the other for something else where there's an unknown quantity. So what I did in my, what I was looking for was this muscle cell. And so I drew another line, the width of a muscle cell, and then this one, so the height was 0.23. And so there's two ways that you can kind of do the calculations, but the point is, I know it's 0.23 inches in my drawing, and then I want to find out how wide is that in real life. So you can do the cross multiplication way, where I'm saying, here's my known, the line is 0.23 inches long, that's the width of the muscle cell, how big would that be in real life? So you can just cross multiply 2.23 times 400 divided by 4.47. The other way that I really like is to start with, this is the thing that I know, this is my cell, 0.23 inches, and then I just come up with what is my conversion factor, again, here based on the field of view, right? So I want to cancel out inches, and I want something in micrometers, and this is the information about that equivalency. So 400 micrometers in real life is 4.47 inches in my image, and then these cancel out, and doing this math, 0.23 times 400 divided by 4.47, you get that, so it's like 20.6, which I rounded to two significant digits, so that the cell should be 21 micrometers wide. So the other part is a scale bar, and I think I'm gonna make a different video about that, but hopefully that makes sense. And then for a width of a nucleus, one of these little purple things, it's gonna be super small. You can see if, again, I could draw another tiny line here, and actually you might want to, whoops, I was trying to zoom in there, but that didn't work. I have to move my little, but yeah, you could just draw another little tiny line, and you actually can, with the width of these, you can type in a value. So, I could say, I actually think it's 0.1. I could get this until it's the size that I really want. I thought, no, that's why, oh, it's this one I was trying to touch. Anyway, I could zoom in on this if I really want to see, exactly the right size that I should get for that cell, right? And I could say, oh yeah, 0.1 looks good, and then figure out what's the real size of 0.1 in real life with that equivalency.